Hello everyone, welcoming you to Sourav Sir's Classes, and today we are looking at the IIT JAM 2024 Economics paper, question number 60. There are two goods X and Y and two consumers A and B in a pure exchange economy. A and B have Cobb-Douglas utility functions of the form given in this manner, respectively. Initially, A is endowed with 50 units of X and 20 units of Y. Similarly, B is endowed with 50 units of good X and 20 units of Y. If the unit price of good Y is normalized to 1, then the equilibrium unit price of good X is how much? Okay. So let's say that the utility function of consumer A depends upon the amount of X he consumes and amount of Y he consumes, which is XA and YA. That is given by 2 times XA 0.4, YA 0.6. Just adding the subscript A for better understanding. And what is the endowment bundle of consumer A? It is 50, 20. Okay. UB, which will depend upon xb and yb, is xb to the power 0.3, yb to the power 0.7. So WB is 50, 20. Okay. If the price of good Y is normalized to 1, then what will be the relative price? It will be Px by Py. That will simply be Px. Okay. So what is the total endowment? W 100, 40. Now no matter at equilibrium, in whatever split the two goods are consumed between the two individuals, the total amount of X that is consumed, XA plus XB, cannot exceed 100, so that will be 100. So that will be true at optimal. And the total amount of Y, YA plus YB, will always be 40. Okay. Now, then we need to define the budget line of individual A. So that will be Px into Xa plus Py into Xp is equals to Px into 50 plus Py into 20. So Py is 1. So Px into Xb. So this is 50 Px plus 20. This is your budget line for individual A. Okay. And what is the slope of the budget line? The absolute slope of BLA. It will be simply Px. And in a similar way, what is the budget line for individual B? It will be Px into Xb plus Py into Yb is equals to Px into 50 plus Py into 20. So that will be Px into Xb plus Yb is equals to 50 Px plus 20. Okay. And similarly, the absolute slope of budget line of individual B would be Px. So if we solve for consumer A, let's suppose the optimization problem, then the optimal will be occurring at, for consumer A, MRS of A is equals to Px. What is MRS of A? It is del UA by del XA divided by del UA by del YA is equals to Px. So that means 0.41 by XA divided by 0.6 1 by YA is equals to Px, which is 2 by 3 into YA by XA is equals to Px. This is the optimization condition. Okay, which implies XAPA is equals to 2 by 3 by A. If you replace it from budget line A, you get 5 by 3 by A is equals to 50 P1 plus 20. So that means the optimal amount of Y consumed by agent A is 3 by 5 into 50 px plus 20. Okay. In a similar way, if we can find out the amount of Y for agent B. So for agent B again, the optimization condition would be MRS of B is equals to Px. That means del UB by del XB divided by del UB by del YB is equals to Px. So this will basically be 0.3 divided by 1 by xb, 0.7 1 by yb is equals to Px, which is implying 3 by 7 yb by xb is equals to Px, which is xb into Px is equals to 3 by 7 yb. So again, if you replace it in the budget line for consumer B, so that will give you 10 by 7 yb is equals to 50 px plus 20. So that means yb star is nothing but 7 by 10, 50 px plus 20. Now if we use the binding condition, ya plus yb is equals to 40, and from ya star plus yb star is equals to 40. If we replace the values, so that will be this 50 px plus 20 part will get common, and you will have 3 by 5 plus 7 by 10 is equals to 40. So that implies 50 px plus 20, and this will be 13 by 10 is equals to 40. So 50px plus 20 is equals to 400 by 13. So that is 50px would be 400 minus 260, 140 by 13. So the equilibrium price would be 140 by 50 into 13. So that is 14 by 65. Taken in decimals, it is 0.215. So the price is 0.21 for Codex. Thank you.